Okay, welcome. Today we're going to show you an experiment with sound and teach you what sound is, how we can manipulate it and use it to manipulate the objects around us.
So, what is sound? Sound is the material around us vibrating. This becomes clear if you try and put your finger in the throat. Try. And then sing a note. Yeah. Then you should feel it vibrating, right? Yeah, but what is this vibration?
So the material around is vibrating, and the waves you're going to show you is traveling wave, standing wave, and pressure wave. So the material is vibrating, and here we have a spring. We're going to imagine that it's the air around us, or a guitar string. And now I'm going to plug it. Okay. Plug it. You can clearly see the wave. So this is a traveling wave. It travels back and forth, and you can also see it recoils from Sara, and this gets sent back to me. This is echoing. But if I time the pulses correctly, we get a standing wave. This is the natural frequency of this string, and it depends on the length. But now, if I try to double the frequency, you can clearly see that there's a stationary point in the center. This is called a node with a D, not a T. And the stationary point is where there's no sound. It's a silent point. And now we can try and triple the frequency. It's a heavy spring, which gives us even more nodes. So here we have more silent points, and at higher frequency, the nodes become closer to each other. But another frequency you're going to show you, another way you're going to show you is a pressure wave.
Yeah, a pressure wave is harder to see and imagine. Should we change the spring?
Yeah.
So if I compress the spring and then release it, you can see the wave, the pressure wave, traveling. And sound is a pressure wave. We can change the speed of the wave by stretching it more or relaxing it. Oh. But sound travels a lot faster than this. You cannot see sound travel. Like when I'm speaking, you feel that you hear the sound at the same instant as my lips are moving. But sound travels faster actually in water. It travels 5 times faster in water than in air. In air it travels 340 meters per second.
But now we're going to use these two concepts and try to explain to you the next object. You can see it on the screen here. So this is a plate, and it's sitting on a motor, just a mechanical vibrator. And as you saw on the standing wave, under certain frequencies we get a resonance. So the waves get a lot of amplitude, and here it's this little pump here, which is going to move the plate up and down. If the plate can move back and forth in 1 second, it's called 1 hertz. If it can move 1,000 times a second, it's 1,000 hertz. And under certain frequencies, we're going to hit the natural tone of this plate. And now we're going to try to, and now she's going to turn off her microphone. And for those with sensitive ears, for the higher frequencies, might want to cover their ears. Okay, so one of the first frequencies you get is here. The sound lines up where the stationary points are, so where there's no sound, so to be. And for the higher frequencies, we get notes that are closer to each other. And as you can hear, in between, the sound isn't that high. But for higher frequencies, we get much more amplification. Here we have a higher frequency, and as you can see, the notes are closer to each other, and this is, so the plate is moving up, down, and then up, and then changing. So in the points between here, the sand isn't being bothered so much, so it wants to align there. And for one frequency higher, we get a much complicated pattern. For frequencies higher than this, the pattern becomes almost indistinguishable between each other, so we're not going to look at that. But now Sara has to leave me, and to replace her, I'm going to need 3 volunteers. There's one. Yeah, come here, yeah. Sara is an important part of this. So one more. You? No, behind you.
On peut les encourager.
Okay. Sure. You both have a bachelor's degree in physics, right? No, okay, that's fine. Okay, now I'm gonna turn the speaker like this. You turn it this one?
Oh, we're gonna get some really bad feedback now.
Yeah. And can you stand over there? You come with me. And you can stand over here. And I want you to stand here in the middle. Now Sara is going to turn on a monotone. So she's going to turn on the right one first, and we're just going to hear a monotone, just a clear tone. And then she's going to turn on the second one. So what happens is that the sound from this one is going to either amplify or nullify the wave. So in the center, you shouldn't hear anything. But there's such that little echoing. Now everybody should hear the same tone, right? Now turn on the second one. No, all power. Okay. If you can try move it back and forth until you find not too far from the center. Found it?
It's not quiet, but it's the most quiet.
Yeah, because of echoing. So the tent isn't completely symmetrical, but if you want to try, so we switch from here and hear the note. Very quickly. Yeah. And then you wave back and forth. So start again. So now you're gonna try. Did you hear it? Did you hear it go down? Yeah, go. So the sound here, if you wave back and forth. Yeah, it's stronger. So you're standing in the note. But now we want to try and could you turn the speakers so it faces the audience? And this one too. To try and let the audience hear the notes. So just start with number 2. Now the audience should hear increase and decrease. Can you hear it? Yes?
It's kind of cool.
This is a note traveling through the audience back and forth. And now you can try this last one. This is a difficult one. You can go sit down again. Yeah, thank you. So this is a difficult one. I'm not sure. Try number 1 and both. Yeah. So the one sitting in the center here and here should hear less, and then you should wave back and forth and try to hear the note. Can someone hear it? Yeah. Here in the center, you should be able to hear it. Can you hear it? Yeah. But now Sara can go back up stage. So usually get sick after listening to this too much, so we can only practice this a few hours a day because it makes you sick. But we're not gonna do the whoo like the other team did because we already did it when we woke up this morning. Okay, thank you.
Thank you, Ernst.